So welcome back, everyone, for those of you that have been here before, and welcome for those of you that haven't been with us yet this fall for the next edition of the Fall 22 WyGISC Geospatial Forum. So great to see so many folks in the room and folks online as well. Today, it's my pleasure to introduce Dr. Chloe Mattilio, every letter, right? She's coming back to us as a recent UW graduate, just finished her PhD this summer, I think, right, in plant sciences and the program in ecology. And now she's doing a postdoc with Dr. Brian Mueller at the Ag Experiment Station in Sheridan, right? Yeah, and so we're excited to have Chloe back with us today, and she's going to talk about a project that she was involved with this summer that was supported by the 9H Foundation. I won't spoil any of the rest of it. I'll just turn it over to Chloe. So please join me in welcoming her.
Hi, everyone. Like Jeff said, I'm Chloe, and if you have questions online or in person, shoot and fire as we go. I'd be happy to have more of a conversation. And there will be some overlap quite a bit from my last wrap-up presentation with my teammates, Ezekiel, Trevor, and Emma, who cannot be here today because they all have classes. But they said, go forward with the presentations, and maybe we'll get some of them to stick around. They were all excellent. So you get a chance to have them in class or hire anybody for summer help. They'd be great ones. Okay. So just kind of introducing the problem here, and what we were generally trying to work with this summer is the issue of pest management on ranches and in production agriculture. There's a lot of challenges to trying to handle the pests you have within your operation. You may have really large acreage, and scouting is typically done when you're driving on a road, trail of some sort. So usually you're moving, and also those vectors that we're traveling, you're really sampling along them, but not so much out in the internal parts of these sort of fields, especially in Wyoming, where you have a lot of flood irrigated forage, which is really, you're not out there during the summer once that water's on. So usually assume, unless you are getting certified, that no one is going to be scouting the center of these fields. Mature forage can obscure your pests, and there's a narrow window for a lot of these pests that they can be controlled at for maximum efficacy. And this trend, I'm saying pests to be more inclusive. We're talking about weeds for one of our portions, and then focusing on insect pests in another. You may also have problem areas that are sparse or widely dispersed. So oftentimes it's really not economical to do a broadcast treatment over all of it. Especially, like I said, everything in Wyoming is irrigated if it's agricultural, unless it's grazing. But we have a lot of differences within parts of those fields. So oftentimes the problem areas are just where there are issues with irrigation as well. So you don't want to broadcast over the entire thing. Most importantly, producers need to quickly and accurately diagnose what the problem is so they can respond with an efficient management plan as soon as possible before these losses can be sustained. And there are a lot of ways that unmanned aerial systems, or UAS drones, could be included with your pest management program on a ranch, especially for getting to difficult to access areas like flood irrigated hayfields, where typically folks would not enter once that water is turned on. So I think a lot of folks are familiar with the 9H Foundation and their goal of supporting especially student research, which is where we came in, the 2022 student team with the SmartRanch, Zeke, Trevor, Emma, and myself. But this is a KMZ file we were given of the 9H ranch property holdings in Albany County, I think all Albany, yes, when we were initially starting out, saying, all right, all of this is fair game. But our goal is to map noxious weeds with UAS remote sensing. We honed in after 2 weeks of my teammates scouting for these weeds, go into the fields where we were told there were weeds and not much happening. I honed in on satellite imagery where there are dry spots and forage fields where whitetop usually grows, and there it was. So we were working right here off the Carroll Lake Road. We called this the home ranch. I believe they call it the same thing. And we had one primary area that we were focusing on where there was a dry spot and a pretty hefty infestation of whitetop. And this is where we did all of our UAS remote sensing for this project. So we had a couple of research objectives and 2 questions to go along with them. Generally, our first objective was to create maps of weeds and study area fields with estimates of detection rates using multispectral imaging and machine learning. That was written into the application. So that's what we did. Our second objective was to develop protocols for whitetop control with UAS herbicide applications. I wish we had more deliverables from that portion, but we will get into that later. But our questions for both of these is kind of, is this a accurate and reliable way to do it? And is it efficient? Would doing this mapping, scouting for whitetop be as time efficient and also as accurate as scouting these fields on horseback or early in the season before the water's on? And would it be efficient to do the application of herbicide in this case and insecticide in the case of mosquitoes with a UAS rather than doing it with an applicator? So I just talked about the home ranch where we're working at. But for our remote sensing project, we were working in flood irrigated forage fields at that home ranch with the primary forage grass being Garrison creeping meadow foxtail. Looks a lot like Timothy. I'm not so sure it isn't Timothy sometimes, but if you talk to a producer, they always say it is Garrison. And this grows pretty well. I've been in Garrison fields that are taller than I am. So definitely a tough matrix to work with, but our specific target is pictured here. There were other vegetation species in this plot. Most notably, we had a lot of allium, a lot of dandelions, wild plantain, yarrow, foxtail barley, and then in the dry spots, the native bunch grasses that were holding on without getting drowned out by the flood irrigation. But generally just kind of annuals that you'd find in sort of these spots. Hesitate to use that because a lot of those are not weeds. That is usually what grows where there's a lot of disturbance. But our target noxious species was whitetop, the Pydium draba, which is a pretty nondescript, very small herbaceous plant. It has a perennial habit though, so it is really problematic once it gets a hold of these forage areas because that root system keeps it going through the year. And if you have whitetop one year, you don't do anything, you can count on typically more whitetop the next year. And it really is a challenge in Albany County hayfields. We had a large patch that was our primary area that we focused on training and testing. And we also found a smaller patch away from that one in the field that we utilized as well. So we were using a multispectral UAS that was provided for us, DJI P4 multispectral ag, I believe is the full line, really just a modified phantom 4 that includes red edge and near infrared with the sensor. This is full disclosure from a different sensor. I just really like to think about it this way. We've got our real color imagery that was collected with this drone, but we also had green, red, and red edge and near infrared kind of hedging that the near infrared would be more useful for differentiating within the vegetation class of the forage and then our target noxious weeds. So this is spectral data, spectral that we're working with for this project. These are kind of, we split it into 4 groups for this portion of the project. The imagery capture, which we use that P4 multi-spec UAS to map these irrigated forage fields, targeting in on the areas that we knew had whitetop. We used Pix4D mapper and ArcMap licenses on the computers up in WyGISC to merge those photos and bands of light into multi-spec imagery stacks. We digitized recognizable training samples of 3 different cover classes in ArcMap, and that was our forage, our target weed, and then bare ground. And then our final step was using RStudio and a machine learning technique to classify this multispectral imagery. Generally, from image processing, we had an 80% success rates for all of our flights. Some of them just did not process. I would suspect if we go in, we had too many image samples at a single location. But overall, 80% of our flights went well. And flight data collection, things went pretty well. A couple times we had missions not seem to upload fully or lose partway through, but generally we had pretty good success rates for flights and processing. And we ended up with a resolution of 1.64 centimeters squared at the 30-meter flight altitude. Because we did conduct flights at a few different flight altitudes. We used a supervised random forest machine learning classification with those 3 classes I mentioned before: our target, forage, bare ground. We did find that our classification performed the best during Whitetop late bloom phase. We went out in 3 different phases: pre-bloom, peak bloom, and a little past. And we did have slightly higher flight altitudes resulted in reduced classification accuracies. We did find that when we added a second Whitetop patch in that field, we decreased our overall classification accuracy and Whitetop detection rates. We think this may be a phenological effect, and we'll get down more closely. This is the, I believe, 20-meter flight imagery from the pre-bloom phase of Whitetop. Pink shows where we have presence locations of Whitetop that were mapped with every square meter of Whitetop that contained Whitetop, took a point. Very clumped, usually how these Whitetop patches go, and also the best way we could get through mapping it all. And here's zoomed in on what some of these look like. This is when Whitetop is more at a basal rosette phase, so there is no fruiting body occurring yet. So basically we're getting out and just take a look at what this imagery looked like and make sure that plants were recognizable. This is our resulting classification of this imagery, where red is our Whitetop, green is other foliage, and white is bare ground. This interspace before it's grown out, there's a lot of bare ground in this dry spot. And we didn't have very encouraging results with a lot of false positive Whitetop. We combed this area, and I can assure you Whitetop was not found outside of this dry spot, which is located here. So moving on to peak bloom for Whitetop, which is when it's got its white flowers. They're still pretty small. I would say 2-inch max for these a single Whitetop flower. And imagery, you can see a little bit more differences, and forage is taken off a little bit. But when we look at our Whitetop, these white clusters you can see are those flower heads of our target. And with the classification, we really honed in on those areas, but we still had false positives beyond, looking like primarily in areas that there is gaps in the forage. This is the late bloom imagery. You can see those same Whitetop flowers are somewhat visible with the presence locations above. They've kind of yellowed a little bit. It's a little bit later in the season. There's not much change, but there's a little. And this classification ended up being our best. And although we still have a lot of false positives beyond our studied Whitetop location. Here is the error matrix, confusion matrix for this classification of our 3 classes. We've got our classification class here on the side, and up on top it should say training class. I kind of ran out of room on this slide. But across the diagonal for each one of these 3 classifications, all 20-meter, but at the 3 different time steps. The diagonal is where we were correctly classifying these classes, and anything off those diagonals are misclassifications. So for instance, in our pre-bloom, we had quite a few training samples of other foliage that we were classifying as Whitetop, whereas bare ground, a little more separable. We see that start to change in the latter classifications, and our overall best classification for Whitetop was pretty well even between the bloom and late bloom, but our overall classification accuracy for these models was improved in the late bloom phase, largely due to the increase in accuracy of the bare ground class though. So if we're shooting for Whitetop identification, there are different implications depending on each timing. You're gonna perhaps confuse more Whitetop with more bare ground earlier in the season, but also have a hypothesis of why that might be. So this is the final set of imagery I'd like to show you folks today. And this is from that larger sample, which include 2 separate Whitetop patches. Our primary one that was studied up here, that you saw in the last 3 imagery sets, And then our smaller one down here, as well as our sampling location trail that we walked over and over. Another reason that it's pretty easy to tell where you walk through these forage fields, which is why they don't usually. And here's what those two separate whitetop patches look like. This is the one that was earlier in this, we've been studying in the past three slides. And this is the new patch down here. For some reason within this field, I'm guessing just due to less water, this whitetop was just a little farther along, and the clusters of flowers that are recognizable here are more characteristic of that late bloom yellow color, which really we have co-occurring species that are yellow blooming or white blooming, really have potential for errors either way. But we did find that we were better at classifying whitetop that was just trained within this patch, not that was trained between both. And here's what that looks like for this large area. One note, we did have to increase our flight altitude to 30 meters for this analysis, just because we were not able to fly all of it on one battery otherwise. So with this one, our overall classification accuracy was 80%, with a greatly decreased classification accuracy for whitetop, 74% compared to 96% of our training samples and the other best classifications. So this brings up some glaring issues for weed management, at least for this sort of site-specific and context-specific goals. We did a better job when whitetop was in late bloom and we were at a lower flight altitude. Whitetop was misclassified as bare ground in peak and late blooming imagery, and vice versa. But in the pre-bloom, it was misclassified as the other foliage, because at that point, it did not have anything that was more than green leaves that were not that separable from our forage. And we did find that it was better identified at the smaller flight area, since they're at the same growth stage, which is something that would be really hard to account for weed management. So our recommendations from this work generally would be that although their classification looked okay accuracy-wise, probably not precise enough to be used for whitetop management purposes, especially since this is a species they're really going to have to get ahead of due to its perennial nature. There's not a lot of different control options for whitetop. So having false negatives can be pretty damaging. And it also isn't really all that efficient for if these folks were going to be trying to do this on their own. So generally, our recommendation would be if you wanted to do this on your property, purchasing a drone that could just do RGB mosaics and looking at that. If you are an experienced enough manager and know what you're looking for, you might be able to get pretty good maps in much less time than if we actually went through the classification process. I think a lot of this is how these drones have been sold to people. I find that when I talk about this sort of thing, they tend to think that you collect the imagery, put it into a program, and after that you get a perfectly classified map of every single different land cover that is within that flight area without the training step. So and that is how they are being sold. I was just at a conference where companies were selling things kind of like this, and I asked, what classifiers are you using? Oh, we got some guy. I think we are the guys though. So we have a lot of questions about this sort of thing. So I think that's one thing that being realistic with expectations might be good, especially when you have different co-occurring species that look very similar. This is an example of whitetop, noxious weed, kind of in the late bloom phase, and this is yarrow that was growing right next to it. A native plant that not a noxious weed, very similar size, very similar growth habit. Weird lighting somehow, but I think you get my picture. It's pretty challenging to be confident in these classifications when you need to know where you're going out to spray. Although I don't think anyone with backpack sprayer is ever disappointed to have less to spray than they thought. So we also were approached to the idea of using UAS for pesticide applications at the 9H, and just kind of in general, this is something that I've seen gain a lot of traction and interest in both agricultural fields and precision weed management, invasive plant management kind of fields. It has a lot of appeal because, like we talked about, these forage fields, you don't really want anyone out in them once the grass is actively growing. That is smashed down hay that you cannot bale. It might be able to grow out of it, but I know that's a big concern for producers. So the crop is not damaged at all by your ground application, depending on what you apply. So let's say that if you're applying on label for what you're trying to do, it will not cause damage. I don't know how high you are mixing this rate, but generally be fine with that. It's a lot less expensive than hiring a manned aerial applicator. Working with folks like this, they get paid by the minute. It is hard to get them to commission. And if you have a small area, they don't even want to worry about it. It's also a lot safer for any kind of applicator on the ground or flying. If you have difficult terrain, steep things, an area along the creek with a lot of it, it might be a good option. It's less dangerous, at least for the applicators. I'm not sure about the UAS itself. And you do also have an option to spot treat rather than broadcast treatment. So if you could ideally tie into fairly accurate classification from the remote sensing round, you could have a great spot treatment map that you could go out and then spray. And that is definitely the idea that is being sold by some companies. I have seen a few do it.
Are there disadvantages? You had advantages there. Are
Sure.
there some disadvantages?
Well, I get into it a little later. This is not very well tested. In lead science, like folks have looked at the nozzle output, the spray pattern, drift, all of these things. And at least for this specific drone that was purchased by the 9H, the DJI Agricu T20, which they no longer make, by the way. They do not make that anymore. So that's never my favorite feeling in the drone world, but that is okay. They're limited by payload and battery. When I've seen folks employ this effectively with the Agricu or another drone, you need to have a herbicide mixing tank ready to go. You'd have water ready to go, a generator with a lot of battery packs. Usually it involves a whole trailer setup, and at least in Wyoming, you cannot guarantee you will have an access point to everywhere you're trying to spray. So my fear would be if you had to spray in the inside of a field, you couldn't drive back into it, you would waste a lot of battery life just trying to get back to the truck. So that is one thing that I worry about with this, as well as it not being studied well. And there's a huge exemption process to go through with both the size of the drone and what you're trying to do with it. With our research this summer, which I felt a little bit like we were just absolute randy rain clouds for the folks at the 9H, we could not legally do anything they wanted us to do. When we got started, we needed to put in for an exemption to fly this drone that is above 55 pounds. We also had to put in an exemption to dispense chemicals and agricultural products with the UAS. And that's really just to show that there has been a plan for what rate you'll be spraying at, the sprayer is compatible with what you're doing, and that there is a whole safety plan for other folks in the area, issues to other crops, really just making sure that since we are flying economic poisons, as they classify them, up in the air and dispensing them, that folks know what they're doing and reasonable measures have been put in place to have safety. And there is an exemption. Even if you got this exemption approved, you're not supposed to fly within 500 feet around buildings and public roads, which our site is not either of those where we were trying to fly this. So some concerns, especially when you have interns for the summer potentially doing this. And we did, though, with this work, submit these exemptions. And I don't want to stress that as not being a major step in the right direction. It does take 8 months, I think, was the estimate for these exemptions to be processed. But one of the deliverables from our work this summer was that these were put in with the FAA. I believe they're in process. But again, we did have to put folks at the 9H in charge of them to make sure there's continuity, since nobody quite knew where any of us were going to be next year. And we didn't really want our names tied into it with follow-up stuff. Would not be super helpful. But these were submitted and they do require significant planning. And it is much like the label of whatever amendment or pesticide you are applying. It is a legally binding document. So once these exemptions go in, things go well, there's room for some edits, but that is the plan. You cannot switch up what you're going to apply. You cannot, change your target species. That would generally require another editing. So we did try to word things pretty broad that hopefully you could target a number of different noxious weeds, but that you would be focused on mosquitoes if you were trying to control insect pests. So no spraying for alfalfa weevil. I don't know if you could even do that. A couple things to note, kind of about just like issues this summer in general. It was a really late irrigation year for them, and not because they wanted it to be. They just did not get water out to the fields they wanted to early on in the season to get forage up and growing. And that was a bit of a challenge. Nice for us because we had one sampling date where we didn't get our boots soaked, but the rest of that, I know that was not as they wanted it to be. And I do think that that impacted both standard forage and probably the weeds as well. Another one, we were told that there was a lot of whitetop in a lot of fields. I did not find any. So I would not recommend this to be something that you would just go out and scout brand new terrain that you didn't already have an idea of what you were looking for and generally where you wanted to be looking. I don't think that would be a great use of time, but I do think they could really tighten up their understanding of where problem weeds are on their property and kind of where we wanted us to focus. The other one, which was a challenge, the primary interest of 9H Ranch was to fog for mosquitoes, but the drone they bought does not have the capacity to dispense aerosol pesticides. So they, I believe, tested it with liquid, which doesn't work because that's not how you control mosquitoes. So we did recommend and write in the exemption just for granular larvicide application to bodies of water. This drone cannot fog. It does not have the pressure or the nozzles to do so. It was purchased with that intent, but I cannot work through that. Perhaps that you could modify some of that, but I don't think you could get enough pressure to dispense aerosols. And as I said earlier, we just don't have any studies on the spray efficacy pattern or drift with the DJI T20. I think that's something that would be really great to focus on for the next round of interns, now that they might be able to fly it. That would be a really good thing to look at. Water sensitive cards with your target, a little bit away from the target, farther away from the target. You could have a really great study, I think, on that. And it would probably make folks a little more, I guess, excited to use this product since they've looked at whether or not you would be hitting the target you're trying to spray.
Another question, since you're encouraging back and forth.
Yeah, please.
So like with this and with the process of this application that you went through and identifying some, that there aren't any published studies, like, would there be value in like considering this, say, for one of the ag experiment station properties where you could sort of get, I don't know, like a multi-year exemption or something in place and say that we're going to set this up for a 5-year sort of study at this university property, or at a partner like 9H, where you could do these kind of tests, or even having like a dedicated drone testing facility where we could do this as new capacity for the University of Wyoming. I mean, would that be a way to sort of get at some of this?
I think so. Well, and I mostly just think that it needs to be conducted by a party that just wants to see how well it works. I know that companies have done some testing. I was just working with folks, I believe they're based down in Florida, who build drones, and oh man, sorry, I missed one in the chat as well now that I finally looked. But I think this would be really beneficial, and it would, I think there's been a lot of private sector push for using drones in every aspect of your ranching and agricultural operation. But I think that as in our role here doing research, it would be great if we could be realistic about these expectations, particularly when it's producers' money that would be going into buying these products that may or may not work very well, may or may not be supported, and may or may not meet their objectives. Just kind of at Ramesh, we talked about, I know a long time ago, of applications and limitations of doing this. I think that would be well worth it. And I think studying, if this is going to become another method of managing weeds, invasive plants, pests, it's got to have some more testing. And I think sometimes you can get away with it in weed science with not doing that because you're not so worried about the other targets. Hopefully what we're spraying on Whitetop as a broadleaf will not affect our forage crop, the grass. But I think if you got into spraying insecticides, people will be a little more concerned that you're hitting your target. So awesome things. And John in the chat, I'm sorry, I see you have a question about a particular package in R. We use the random forest package, and we chose R because I had a workflow that was built to utilize this sort of imagery. And also, we wanted to have a little more control of whether or not this could be utilized in the future with 9H, since our studio and ours is an open source program. They would not have to get a Esri ARC license or account of any sort. So that was something, and we did, and I messed with it a little. Truly, if we wanted to have it all open source, we did not utilize an open source mosaicing program for the imagery that we collected from the drone, and we could have used though a QGIS program for digitizing and kind of managing the spatial data. So yeah, we were trying to keep it open source, but cheated a little bit using Pix4D mapper and with ArcMap for digitizing. John, I hope I answered your question. Okay. Anything else? Okay, so looking into and this was something that I have to say, Trevor and Ezekiel really put together, because this was something they're very focused on, and maybe burnt on forever, how complicated and time intensive this program can be. And they wanted to see, well, what would it cost? What does this cost if we price it all out? And we came up with, between our drone that we were using, charger, batteries, another drone for the multi-spec, an iPad, because for some reason that drone only worked with an iPad. You could not use Android devices at all. So we did price in buying an iPad, and not an iPhone, an iPad. So again, no longer supported app. We were doing our best there. Calibration panel, mosaicing software, ArcMap license, again, our studio being the only thing that's free. 2 GPS units, I believe that's the price of 2. And then your Part 107 exam to even have your license, you come up with a total cost of $42,809 with $1,500 annual cost, or a $37,819 cost with a $4,200 annual cost after that. There are two, and only the 2 options here for the Pix4D mapper and ArcMap contribute to the difference in price. So this is pretty expensive. I just met with folks last week in Cody who were using this in Hot Springs County to spray, not the same drone, using a company that actually put in the exemptions for them, built them a drone for their purposes, and helped them to get that off and running. It was $47,000 all in. So gotta make money make sense. So that's kind of our note for this. It is a pretty expensive undertaking. I'm not sure of a lot of operations that would be able to do this as a plan for their operation without being sure of the payoffs. But for some more future project suggestions, which I really hope, and it sounds like work will continue with the 9H and with this internship, it was a really great opportunity. It was a good start, and I hope that some of these things might be able to be incorporated in the future. We were going for a pretty tough target. Whitetop's pretty inconspicuous. I think focusing in on more identifiable noxious weeds that are just larger, have a more colorful bloom, and maybe have a longer blooming window than Whitetop, like thistles, would be a good option. The only problem with that, although the 9H is not currently certifying any of their forage as being weed free, if they wanted to, They would probably have to target things a little earlier for mapping, because you have to make sure that for your forage to be certified, you can have weeds in it, but you can't have any propagules. So they would have to go out and either cut off the heads of thistles, something like that beforehand for it to pass certification. So if that's something they want to do in the future, timing is going to be critical to still be an early season before they take the water off. So, wet boots for folks ground truthing in the future. Also, and this was one that Trevor and Zeke were interested in potentially would be using that multispectral camera and drone to measure forage productivity, not trying to map weeds themselves, but looking at kind of, I guess, NDVI being just the easiest to see if there's any wet or dry areas they need to get out to and perhaps fertilize, though I don't think fertilization is necessarily feasible for a lot of these areas or folks. Oops. And one thing that they had mentioned at the end of the summer would be the interest in making fine scale elevation models of forage fields to better plan irrigation or adjust where they'll be putting those lines in. And that would have to be fine scale. Because I think that could be a good thing for them to focus on and something that would be of interest. As I said, for the exemption and our recommendation for them moving forward would be to use granular larvicides for control of mosquitoes, not any UAS application of a liquid or aerosol formulation. And finally, firm expectations of the objectives and student participation. When we first started, we had a bunch of targets we were talking about and things, but we had to kind of go from initial goals to problems that are faced on the ranch to what can we find. We initially had a lot of targets planned and ideally wanted to have a lot of sites. But there just wasn't a good enough handle on that. We spent a few days just driving around all of those properties, getting asked how lost we were, trying to figure out where we would find more weeds to focus on. And I think also when it comes to anything with applying pesticides, takes a lot of certifications to do that. Probably should not be in students' hands. Luckily, we had enough red tape that it wasn't. But I think if they are going to be doing that for future summers, being clear about what they'll be spraying where, which should be in the exemptions, all included. So in case something goes wrong with that treatment, the applicator themselves is not liable for what happens, especially if you're dumping larvicide into lakes. The water bodies there are already, a few of them are currently being treated with, I think they're with Albany County Weed and Pest, but they are already putting granular larvicide out in some of these bodies of water. This would just be a different method for doing so. Yeah, so any notes or questions about that before I jump into just the last couple things, which we are working on. This is a picture from some of the forage fields I worked with in Elk Mountain, where we were trying to do a similar thing, mapping weeds with UAS, and they've got thousands of acres that they cut hay in, and this is how they usually do it side by side. Even with fixed wing drones, even with bigger and bigger payloads being built in, that's still a lot of ground to cover. Again, with the nature of weed management in these forage fields, you don't need to broadcast over all that, but if you don't cover all of it, you won't necessarily know. So I do think there's a big limitation there for using UAS for mapping. Again, the consequences for false negatives of weeds is pretty damaging. Especially if somebody said, we surveyed your field, we did not find any target weeds, and then the certifiers come out and say, you've got a lot of whitetop, we cannot certify this hay, you're gonna have to sell it at a lower price point. People would be pretty unhappy. And also the last one, and this is just kind of a caution that I've been seeing, the estimated costs and deliverables, I should have included that as well, do not account for the user training and education on this back end. A lot of people, like, I'm not very good flying a drone. I do my best, but I can get it up there, collect imagery, come back in, but that's really where the hard part starts. And I don't think that we are quite selling that well enough to producers who are purchasing for this further operation, which is occurring. Yeah, that's what I've got. I was hoping you guys would be a little more chatty going through, but yeah, please, anything you have now that you'd like to talk about or like to know more?
Questions for Chloe? Lots for Chloe and then questions.
Question. So, yeah, from when you were talking about the type of drone that they don't make anymore, now, are we talking about two different drones between the imagery and then the applicator? Or like the one that can't apply it, I guess is what you were talking about, like.
Right, yeah, so the one they purchased, the Agricu T20, that's just the capacity, it's 20-liter tank, for the herbicide or pesticide, excuse me. Yeah, that one they are not making anymore, but they are making bigger payloads. So they keep going bigger and bigger with them. So that's kind of just the main one with that.
Oh, okay, so maybe it's just got upgraded and they don't make the old one anymore. But oh, okay, sorry, no, I mean, okay, I was just wondering though, is it like, was it discontinued for some reason? But just answer that, then also, are there drones that are qualified or available or multi-role like that you identified that would be a good drone? Like, cause I bet you people just go out and buy a drone and they're like, now spray crops, and it doesn't work that way.
No, not quite, unless you purchase a lot of other things. I don't know of anything available that is not, like, well, at least it's commercially available, say that can dispense aerosols. That just needs a lot of pressure going through, and it would be great if you could, because a 9-inch ideally would like to be able to go out and fog for mosquitoes over their cows when they're getting all balled up in the corner, when the pests are just really hard on them. They're just waiting for that wind to come and blow them away a little bit. That would be their goal. I would be intrigued to see how the cows feel about that. I'm sure once some of the moms figure it out, it would be fine. But I don't know of anything that can fog yet.
So okay, sorry, last follow-up. Is it just like an aerosol drone's not allowed to do it? Is it like some hard and fast rule that they have, or it's just they don't make no one's been able to make something that does that?
I just don't think that anyone's been able to set up a spray rig that works while flying. I know at least when they fog around, and Zeke was really cool, actually ended up working for Albany County mosquito control. He was the guy driving around at night and then coming into work exhausted the next day. But they aim for an hour of hang time when they fog for mosquitoes. It's kind of difficult to achieve, just really, really high pressure and tiny, tiny nozzles. I don't know how advanced people have gotten with those robotics. I'm sure there is someone out there building them, but nothing that you can buy right now.
Okay, well, thank you.
Yeah, just a quick aside, like you mentioned Cody, and just, I don't know if you've heard of the NASA Develop program, but we've been, for the past 10 weeks, we've been working on a project looking at turbidity within the Shoshone River being released by the Woolwood Dam. And next week, we're going to visit the study site finally, so yeah.
That would be really cool.
Yeah.
Should be beautiful.
What influenced your decision to go with ArcMap instead of QGIS to keep it open source?
That was mostly me being able to build a model builder for other folks. For each part of this process, we were working on locally desktops upstairs. Something hopefully I'll be talking to Shannon about today, of just finding a way that we could share data in a way that was easier than that. But I kind of used ArcMap just as a way to wrangle everything that I was familiar with, and that other students did have some exposure with before.
Okay.
At the end, I think it would be a pretty easy conversion. We were not doing anything that QGIS is not capable of doing, or fewer things to have to work out than doing it all in QGIS. But yes, could easily be converted to from ArcMap.
Any sense at this stage for these types of applications, what the useful life is for one of these sorts of drone?
Could you repeat his question so folks online could hear?
So the question was, any idea about the useful life of kind of these products? Am I getting that right? Sure, I can speak from my experience of trying to keep things commercially available is really challenging. It comes from a good place of wanting it to have a package you can recommend to people to use. But during my 5 years during my PhD, I think I used 3 different drones just because things were no longer supported, no longer working. And it ended up being the one with the best imagery was the first one that was a 3DR solo, which was so long ago. But I think here, if you want to get sustained use out of it, I would recommend finding somebody that can work with you for your needs and building the drone. I think that's your best bet at finding something that will have continued use. I would say the DJI products don't seem like they're going to be going away anytime soon, but it does feel like there will be turnover in what products they make, what batteries go with them, what programs you can use to fly it. And that was our issue with the multispectral drone. It only used one program and that only ran on an iPad.
So kind of related to that, in some states, in cooperative extension, there are positions called geospatial extension specialists. We've explored that a little bit in Wyoming, but never been able to sort of formalize it. Long time ago, there was a joint program funded by USDA and NASA, I think. And some states still have that. Do you think there's enough demand for, and if there were funding to support, a few positions that are these sort of geospatial extension specialists that could help people with this kind of stuff?
I think that would be great. And I think it would help us, as we talked about a little bit earlier. I don't know how many of you folks work with wind and trying to share data. I think that if we had some sort of role of helping folks with their geospatial data, we would have a lot less data siloing in different county offices and different places. And that's just the nature of how things have been done. But it puts a lot of pressure on UW. Already, I have been trying to show people that they can download lots of layers from this wonderful clearinghouse that WyGISC supports. That you do have the power to do some of this. I think that would be a great thing to invest in. I don't know where you would place them, and I know that's a concern. We have working with weed and pest. They don't like doing stuff with the university because there's too much turnover. They don't know when somebody's gonna be gone and that data is never gonna come back to them again. And there's a lot of concerns about it, but I think that would be a great role. And I think there'd be a lot of interest. I don't think I've presented on anything to do with UAS where I didn't have a couple folks come up and say, oh, we just bought one to do this sort of thing. So yeah, and people are very interested about it. I think people will be surprised. And I also know that that's something that UW Wyoming forage would like to get somebody to coordinate something. I don't know who those nerdy kids are that want to talk about GIS, but I appreciate it and think that's something that if we could invest in that, it would really help producers and just folks get started.
We got time for one more question, if there's one in the room or online.
Unless there's one there. Okay. So I guess about the classification, especially when you showed the two comparison of like not weed and weed, like that's, I don't know how the heck that you're supposed to sort that out, I guess, but I guess I was wondering before you showed that, like, could you subtract everything that, instead of trying to identify weed, could you maybe identify things that weren't weed and then take that out and then assume weed? But that's not, like you're saying, damage stuff and be harmful. I don't know if you just tried that at all, maybe.
Thought about doing that, and it kind of like, all right, we got really good at saying like, this is vegetative, this is forage. So the gaps in between, dry spots, rocks, stuff like that could be, and we talked about that, but for actual species ID of like knowing what you're working with, which they do need for any sort of management plan, just not quite accurate enough. So hopefully, I think if they had RGB imagery, knew what they were looking at, a producer could get something out of that. But I think there's work cut out to be doing this. And I think it would be interesting to try to do more UAS sensing, not in forage fields, just because it's such a densely vegetated matrix. I think if you were trying to do weed mapping on a rangeland, where there is more interspace between plants and there is like a bare ground component that isn't like in our case exposed water, you might have very different results. So, or in row crop agriculture, where the crop is in the row.
Yeah.
And anything outside of the crop is probably an issue with your planting or weeds.
Yeah, okay, cool. Thank you.
Excellent. Two things. we're gonna thank Chloe one more time, but then don't run off because I just want to make a couple announcements. So this has been really great. Thank you so much for being here, and please let's thank. So before y'all run off, just a couple things. We talked a little bit about data management, things like that with this project. Tomorrow, if you're interested, from 12 to 1 in the new engineering, building the EERB atrium, the Wyoming Innovation Partnership Data Hub project will be sharing out the results of the 4 demonstration projects that they supported, and that's all sort of about data integration and taking data to the next level. So that's happening. Austin, we heard just real quick about the NASA Develop Group. Is there going to be an online presentation that'll be open to the public about that work? Do you
That's
know?
a great question. So my to-do list today to send out a flyer. It's Monday, I think in the afternoon. Will you?
Okay.
Monday 3 Eastern.
Okay, and that's open to the public?
Yeah, I'll send an email.
Okay, awesome. So that's coming up, so watch for that. And then next Wednesday is GIS Day. And so there are some things going on related to that. So Dr. McMillan will have some details about that. I know one thing in particular, we have this new state chapter of the Women in GIS organization, and there's a lunch from 12 to 1 for that. That is not just limited to UW folks, so other people in the community that might be interested in joining and whatnot. So look for details about that. And I think that's it. All right, so thanks again, everybody. Have a good rest of your day.